So, welcome back to our weekly series of discussions around microscopy. And in the last few weeks, we have been looking at various ways of uh, looking at very small objects using things that are normally available at home, or tweaking things around and repurposing them so that we can see small objects. And we discussed very briefly some of the optics behind all those things. So some key things we'll see if any of our audience recollect any of those aspects. So any of you here, like can you tell us, like, what are the things, can you tell all the viewers what are the things that we discussed in the last few sessions as microscopes?
Yes, sir.
Yes, Black Rose.
We was nylon thread.
Uh-huh. Okay. So we saw nylon thread, zoomed picture of nylon thread. Okay. So what are the how did we see this nylon thread, Black Rose? Do you remember how we made the microscope to see the nylon thread? So we did something to our mobile phone, right?
Yes.
Yeah. So what did we attach to the mobile phone? If you remember, anyone else also can help, because there are some new viewers and new participants also here. Hi, Priya.
Hello, sir.
Yeah. So these conversations are basically around microscopy, and this is a series that has been happening for the last, I think, 3 to 4 weeks. So every Thursday we discuss that. And Black Rose was telling us that she saw zoomed a close picture of, or a magnified picture of, nylon thread. So others, Farhan, Firoz, Prashant. So what are the different? Yes, Black Rose.
Sir, he was with the rice also. Rice.
Yes,
Then
yes. And then we saw a lot of pictures last week as well. Rafiq Bhaiya showed a lot of them, if you remember. So how did we see all these things? Anyone else? Like what we discussed multiple ways of making a microscope. What are some of them that we discussed?
First, we open the laser, normal toy laser, and
Okay.
उसको ओपन करके हमने उसका लेंस ओपन निकाला.
Okay.
फिर हमने एडजस्ट करके फिर कैमरे के जो कैमरा होता है फोन कैमरा के उस पे एडजस्ट किया.
Okay.
Then we click some pictures, and last week Rafiq sir shows fold camera.
Full scope, yes.
Full scope camera. This is also kind of some lens जो हम मोबाइल पे फिक्स कर रहे थे और उस पे मल्टीपल फ्लावर्स के वो इनर पार्ट्स जो होते हैं उसको उसका पिक्चर्स देखा था.
Yes. So these are the two things that we discussed. We also did something else also. Prashant actually made the entire thing. Yes, Prashant, you wanted to say?
No.
So you actually made a microscope. How did you make it?
Okay, means I have unscrewed the webcam, and then in that I found one lens which is attached to CCD, means camera sensor.
Okay.
I inverted that lens
Okay.
and adjust lens distance and CCD means sensor distance, and click photo. Means
Okay.
it is converted to microscope when I
Okay.
inverted that lens.
Okay. Okay. So I think broadly, thanks Farhan, Prashant, and Black Rose for giving us some idea. So we discussed all these multiple ways, and I think if you look at some of the threads on MetaStudio, you'll find descriptions of all these discussions as well, and even on the previous videos on YouTube, you might find them. So we tried to take out a lens from normal laser pointers that we have. If you remember the ones that we use to play around or to point at things, so it actually has a small lens inside, as slightly smaller than shut buttons. Things of this kind like nylon thread, rice, and very smaller. You can see these are all still visible to the naked eye, but you get magnified pictures. And fold scope is again a very frugal uh, instrument, and it looks just like a visiting card, like a very small uh, cardboard piece kind of a thing, inside which there is interesting way of setting a lens, and even that can be attached to a mobile phone or directly viewed to magnify images. And the third one that Prashant did with his um, webcam was using I mean a simple tweaking. So you open the webcam and you invert the lens, and that's it. When you connect it to your laptop or anything, and place sample on the near the lens, you'll have to do some additional setup so that you can mount the slide and move it for adjusting focus. And that also works as a simple microscope that you can make at your home if you have webcams. So these are the things that we discussed in the last few sessions. And so what are we going to do now, Ravi? Okay, so I see Drishtant asking, he too has a webcam. How do we jugadify that? Yes, so Drishtant, like we can very briefly tell you. Yes, please share images. So can one of you share the link to that thread? Uh, wow. Yes, Priya, you want to tell us more about what you do with that full scope? I think Rafiq will also can ask our settings.
So basically, I have that my these scientists. So she had that, but I haven't used it. So now I am very interested that how to use it. I want to learn that from her, as people have worked upon the folder scope.
Yes, yes. Rafiq, you want
So
to add something, or you want
No,
to?
let Ravi start with
Sure,
what he
sure,
has planned.
sure.
Yeah.
So Priya, we will get back to how to use a fold scope and what all you can do with it, because you already have. Maybe you can also do it live when we speak. So
Yeah, just to
okay, okay.
give a maybe Priya, you were not there in the last session. The last session, like we discussed the fold scope like in detail. Like there is an entire 1.5 hour documented video also. So we will share the link with you also. Like we might not be able to cover all the aspects, but you can definitely
yes,
go back and look at the video, and then we can discuss that further in maybe some other time. So, but yeah, like as DP mentioned, like it might also be possible to, yeah. So we'll share the link. Um, but yeah, like today's plan is basically to extend the discussion of like whatever we did uh, in the past few session to take it to the measurement aspects. So generally, like when you
Ravi, I just wanted to say one thing to Priya.
yeah
I will be having introductory session for another group. It will be online. So when it is announced, I will share the link. So maybe you can join that. It
yeah
will be
great.
basics
Sure.
of Foldscope.
And Rafiq, so when we are planning to when you are likely to have this session?
See, basically, this is to be announced by the. There is this one organization, a school in Chennai. So
Okay.
they have Foldscope, so they want to start with it. So it's up to them, no. So I don't know when
Okay,
they
Yeah,
will
yeah, yeah.
do it, but
yeah,
maybe next week, most probably.
nice. So yeah, so Rafiq, you want to add to this measurement thing because
Yeah,
last
yeah.
session we discussed fold scope in detail. We saw some of the very interesting collection of pollens, which you showed us the picture, and but I think we didn't got time to talk about like two parts. I think when we were discussing, one was the investigative part. Uh, what kind of investigations we can carry out using whether we have fold scope or we have a laser pointer microscope or a web camera based microscope. So what kind of questions you can ask, which you can explore on your own. And secondly, like the measurement part, like if you take an image and if you want to like approximate the dimension of object, so how do you do it? So
Yeah. So I think so far you guys have been actually uh, figuring out different ways to have a frugal microscope, be
Yes.
it using the lens from a laser pointer or webcam or full scope, or even the one easiest way of doing it is meaning it is not permanent, but you can just simply put one drop of water on your phone lens.
Mm-hmm.
Yeah. So and it's up to your skill. The smaller the uh,
Drop.
drop, bigger the magnification.
Mm-hmm.
Yeah.
Yeah.
And if you could find any liquid which see, water is not very stable.
Mm-hmm.
So let's say if you can find any other liquid which is clear but is stable than water, then
Mm-hmm.
it can be, you can make a really nice lens also.
Mm-hmm.
So glycerin is one option.
Okay.
Yeah, but glycerin, that or oil is another even better option.
Okay.
Uh, I'm not sure about the some gums, no, these market
Glue gun
you
kind
get,
of a thing.
yeah, glue gun, that kind of
Yeah.
thing, but transparent.
Yeah.
See, transparency is the biggest this thing. So basically, you can use any of these, or you can just simply buy really small these lenses, which like GN bought, no,
Yeah.
really
Small
cheap ones.
beads.
Yeah, beads, and also there are some lenses you get in Mumbai
Mm-hmm.
near Crawford Market. You can actually have these small glass lenses,
Okay. Okay.
and then you can be just creative in designing a holder which can be attached to your phone.
Yeah.
Yeah. So
Yeah.
that is up to, I mean, there are multiple ways in which you can do that. The smallest one is that you just take a piece of plastic or something, cut a hole, put the uh, this,
Bead inside it.
yeah,
Yeah.
bead or lens or into it, or maybe you can have it like a clip,
Mm-hmm.
the clip we use to hang our clothes, something
Mm-hmm.
like that, so
Mm-hmm.
that it can be hanged to phone. So that all those things can be done. So
Yeah.
now
So the other
what?
thing,
Yeah,
I think GN tried out or is using the safety pin.
Yeah, that is, yeah.
So
So it is up to your imagination.
Yes, yes.
Yeah. So now let's say you have some microscope out of these, or you have multiple, because uh, for different object you need different magnification also.
Yes.
So you cannot just use USB camera microscope for viewing any kind of object, size, and also the transparency and all that. These things matter. So for example, let's say you have opaque object. So let's take an example of let's say you want to observe the sand.
Yeah.
Beach sand. So some of it might be crystals, the quartz crystals. So those may be possible to observe when the light passes through it. That is transmission. So in USB camera, what you do is basically you put object between light and the lens. But that is not useful for any kind of object. So in the sand, if there are other things which are not as transparent or translucent as let's say quartz, in that case what you have to do is basically shine light from the same direction in which the lens is.
Okay.
Right. So then it is reflected light. So depending upon object, you will need different microscope, or at least different arrangement of light
settings. Yeah.
Right. Then let's say you have light, you have a microscope, and you have photos. So now what is the next task? Next task is that you need to find out, because we are making these microscopes, these are DIY microscopes, we need to find out the magnification as well. Right? We should have a rough estimate of what is the size of the object we are looking at.
Yes.
Right. So now what happens is basically you take photo, the object looks really big, but how big? So can you how do you basically go about figuring out the size of an object?
Okay.
Okay.
So if what you are saying is, if I am looking at an object, say a pollen grain, or even say something like a hair, or say a grain of a sand, and when I look it on my microscope, it would appear much bigger than that.
Correct.
Right. And what you are now saying is, we'll have to find ways of estimating the magnification of whatever microscope you have used.
Yes. Once you figure out, let's say you have a lens, maybe you created a microscope using some lens or USB or something like that, and depending upon the quality of the lenses in those, the magnification will change. Not all USB cameras microscopes will have same magnification.
Yeah.
So once you have your own microscope, so you need to at least once figure out or calculate its magnification. Later on, you have a rough estimate that you know that my camera, let's say, magnifies 50 times or 100 times.
Okay.
So later on, what you can do is, okay, so I have a photo. In this photo, the object looks like maybe 5 centimeter in length.
Okay.
So you know how to calculate the exact length of that object. So basically, you just divide the apparent length with the magnification. Right. So 5 centimeter divided by the times.
Yeah. So I'm assuming, say it is 50x.
50. Yeah. Let's assume it's 50.
Yeah.
So it will be
1/10 of a centimeter.
Correct. So that is actually 1 mm.
Yes.
So this is how basically we need to do it. So the best way to do that is, what you do is you take an object of known size.
Mm-hmm.
Okay. So I'll show you something. Just a minute.
Yes. So I think this is also sort of a process called as calibration, if I'm not wrong. So is there anyone else in the audience who worked with different instruments and try to calibrate those instruments? I think among our Cube friends, there are some who do that. So
Yes, I used to work with microscopy, and of course, like in school, also a lot of people do what their calipers and all. So then
Mhm.
also they try to look at, I think, calibration in that sense. I did it in terms of microscope only. So we would create, like we know a scale kind of grade. We will put it under the microscope, take a photograph of it, and then we will see how many pixels are 1 millimeter apart or something like that, and then we
So
will
you're
convert it
using
into,
the scale, which is a
yeah,
standard thing. Yes,
yeah,
yes. So that's
yeah.
very interesting. Yeah.
Yeah. So even in this case also, I think people can just use a standard scale, like assuming that it is, mm, of course, there are like, least count and all those issues with the scale as well. But I think if we can pick up one scale, and with that scale also, if the millimeter corrugations are there, you can convert it.
Yes.
That shouldn't be very difficult.
Yes. Rafiq, you're muted. There was some echo. So yeah.
Okay, okay. Yeah. So what DP said is correct. So basically what we are doing is we are calibrating.
Yes. Yes.
Okay. So what I do, it's not necessarily that you have to do.
Yeah.
What I do is I have this, where is this? This slide,
Okay.
which has graph like markings on it.
Okay. So it's a scale.
Yeah, it's a scale.
Yes.
Okay. And here the smallest square
Uh-huh.
is of 500 by 500 micron,
Oh, okay.
meaning 0.5 mm.
Yeah. Yeah.
Okay. So I use this for calibration.
Okay. 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 So you basically, whatever microscope you have, you basically look at this particular slide, which has which is actually a scale of the minimum the resolution 0.5 millimeters, and you'll see
Square.
how big it becomes using that
Yes.
microscope.
Yes.
Yes.
Right. So now it's not necessary that you should find a slide like this, but it is easy to get also.
Yes.
Or what you can do is you take your graph paper
Mm-hmm.
and put it in your microscope.
Okay. Okay. Okay.
Yeah, but if it is 100 magnification is more than 100 or around 100x, then the regular graph paper won't work, because generally it has I think 1 mm,
Uh-huh.
1 mm square, so it
Yeah.
will go out of the field.
Yeah. Yeah. Yeah.
Yeah, but in the market uh, you can go to medical shop or something.
Mm-hmm.
uh, they sell this kind of slides,
Is it?
especially for pathologies.
Okay. Okay.
So in the pathology, they use it to, in the older times, they used to use it to count CBC, blood cells and other things.
Okay. So they count number of cells in each small grid and they estimate.
Yeah, yeah, and then estimate.
That's interesting. I
Yeah.
never knew that.
Okay, so now what is the other object which is possible for you to find in home, and you know its size, but it should be really small, which is
Yes.
visible through your microscope. So
Yes.
one option is a hair.
Uh-huh.
But what happens is we all have different thickness,
Yes.
hair thickness.
Yes.
So what we can do is we can use another calibrated, if we have microscope to first find out the thickness of our hair and then use it. But that is not, I think, work here. So let's think about some object uh, which is whose size we know.
Yeah, so we'll hear from our audience.
Yeah.
So what are the things that we can use other than, say, a scale or a graph paper that is easily available at home, जिसको देख के we can calibrate any microscope that we build, any of these 4 things that we saw?
Rafiq, I have a question.
Yeah.
The slide which you just showed us, like, is it called stage micrometer, which we use in the for calibrating microscope, or is it something different?
See, basically, you can actually call it stage micrometer because markings are very similar. But this is actually, these are slides. Basically, these are grid slides.
Okay. Yeah, the least count you told it's 0.5.
Yeah. So
mm.
this is basically, this is just the PVC strip which you can attach on any slide.
Okay, because we had I remember, like, Jude and Ashish were experimenting with the microscope, so they used the stage micrometer, and that was actually costly. It was
basically you can use any marking which is like below no 1 mm.
Yeah.
Prashant is saying something about grating. Prashant, can you tell us more about it?
Oh, that's a good actually option.
Means it has like a slide thing, but it has more lines. Means 1500
I
lines.
think, Prashant, that's a great idea.
What is
what we need to do is, Prashant, we need to find out if the grating thickness or number of gratings in 1 centimeter or something like that, whether it varies.
We can. No, it not varies. It is constant.
Oh, then that's
grating.
that's a really nice suggestion, Prashant.
But what is a grating?
Yeah, Prashant, you would like to explain?
Yes, grating is.
Also here, Prashant. Yes, you
Okay.
can explain to them. Yeah.
Means grating is like a glass slide, but it has a specific dimension. Means it will be in square or rectangle form, and it has thin lines in that glass. Means 1500 lines in 1 centimeter.
Okay.
It is transparent, and when we means focus on with telescope, we can microscope.
Okay.
We can see each line clearly.
Yeah.
But
so
we have experiment.
Prashant, I thought you're talking about grating on DVD.
Which grating? No, I'm not talking about that. I'm talking about this. It is like a glass slab.
No, that's a good idea, but we still have to find this slide. We are thinking about some objects which are at home. So, but that your suggestion gave me this idea that these slides, DVDs, no, they have these gratings on it.
Okay.
Not
but
the
it will vary.
Not the empty one, but the used one.
Okay.
Yeah, so I don't know whether it will vary or not. That we need to find out.
Means it is used in physics lab for experiment, which I am talking, for checking microscope.
No, that is correct. I know that part, but that will not be available for everyone.
Right.
But this DVD thing, I think, is an interesting thing that we could. Yeah, so we just need to find out whether, see, the needle which makes those grating is one, right? It is constant, no? So it won't make so the grooves won't vary actually. Yeah.
Okay. Means I have a lot many CDs. Means I also can check that.
Yeah, so we can check that one. That's a good idea.
Yeah.
Okay. So now I'll show you how to go about it.
Yeah, yeah.
Okay. So see, what you can do is without app also you can do it. It's not necessarily, but app makes life very easy, and also our accuracy also goes. I mean, it's a quite you get quite accurate results. Okay.
Okay. Okay.
Yeah. So can you? So I'll let me share my screen.
Okay.
On the phone you can't do, but no.
No, you can't share your screen on phone.
Oh no.
Right.
Ravi, I had an app which I wanted to show, but
Yeah,
let's check.
is it possible, Rafiq, like to share the link and some of us can download and then experiment? Maybe we'll not be able to see on the screen.
Yeah, that is a good idea. Let me share an external video, uploaded presentation. Okay.
Yeah. Meanwhile, Shraddha, you were trying to say something about vernier calipers and micrometer. What is that?
You are now unmuted.
Means they have least count of 0.5 mm like that. It has
No,
small
Shraddha
length.
was saying something. Yeah.
That vernier caliper and
Yeah,
micrometer.
yeah. So let her.
Is in a physics lab to measure small length.
Ravi, can you share that photo I sent?
Yeah. Okay.
Just show on the screen, and I'll first explain here.
Okay.
Yeah. I think Piyush, can you please undo whatever you have done by clicking on the back button? So if you click here, I think you can remove whatever you have made.
You are now
He has left. I'll
Okay,
join
okay,
now.
okay. Not an issue.
Now joined.
Yes, Shraddha, you can tell us as Ravi uploads the picture and gets it. Yeah.
These are measuring instruments to measure a small length of like a 0.5 mm, and
Okay.
so based on the vernier scale and the measuring scale, the minimum count of the instruments are measured. So it is different for different instruments. Like vernier caliper have different minimum count, and micrometer has different. So these are some instruments to measure a small length.
Okay. So,
Measure.
yeah. So what we are trying to figure out is how much of a magnification the microscope provides. And I think what we do to vernier calipers or a micrometer, like we'll have to do something similar with a microscope. We'll have to find what is the specifications or what is the magnification of it. And yes, I think Ravi has uploaded some picture. So what is this about, Rafiq or Ravi?
Yeah. So this is a picture of the slide I showed you.
Okay.
And those circular things are pollens inside.
Oh, okay. So
On the slide.
the 50 mm, sorry, 5.5 mm slide that we talked about. Okay.
So so what how do you sketch on it?
Yeah. Sorry. Yeah. No, you can.
Yeah. Okay. So basically, from this point to this point,
okay.
this is 0.5 mm.
Okay. That is 500 micron.
Yes. And see this now on the screen how much it looks, how big it looks.
Yes. So on my machine, I think it's almost 4 to 5 centimeters.
Correct. So now can we calculate the magnification?
Yes. Should we try that? Shraddha, Priya.
The
So
object which is 0.5 mm looks
5
50
centimeters.
sorry 50
5
mm.
centimeters. Yes, 50 mm.
So just same unit we should have.
Yes.
Just turned this thing into yeah, your cm into mm.
Okay. Okay.
Yeah.
So 0.5 is appearing as 50 mm. So how many times did its size grow?
How many times it has become?
Yeah, how many
bigger?
times it's bigger? Yes, Farhan, Prashant, others can also tell us.
100 times.
Can you repeat again, Shraddha?
100 times its size has increased.
Okay, 100 times. I think Shraddha is saying it has increased 100 times. Are there any other responses, or does everyone think that it has increased by 100 times? So an object of 0.5 mm has become 50 mm, is appearing as if it's 50 mm. So how did you get this, Shraddha?
By calculating its magnification.
Yeah. Can you tell us how you calculated? Yeah.
Sir, apparent size versus actual size.
Okay. Okay. So apparent size by actual size, which is 50 mm by 0.5 mm. So there are 100 0.5 mm in a 50 mm. So I think that's how Shraddha got 100 times.
Yes, I think she's correct, right? It looks that this is 100 x
Yeah.
magnification.
Farhan, you wanted to say something?
नहीं मैं क्या था इसे 100 times ही है।
Yeah. Even he typed 100 times.
Yeah, on my screen because I'm using phone, it is around 2 cm, meaning 20 mm.
Okay.
Yeah. So now I wanted to talk about this point also.
Okay.
So because now what we did is we actually the apparent size came from the screen.
Yes.
And the screen has done some magnification.
Yes. So if you are seeing something on a mobile phone, it appears smaller. If you're seeing it on your computer, it appears a little bigger. If you're seeing on your television, it's much bigger. And if you're seeing on a movie theater,
So that is magnification. That
yes.
is what is changing is magnification.
Yes.
But now I want to also introduce two very important things, which is very important in microscopy.
Okay. Which
are so this is so the same image looks bigger on bigger screen. And the other way of doing it is I can zoom it also.
Yeah. Just
so when I'm zooming it, so for example, if I zoom it, then maybe this even the single colon can become 1 centimeter.
Yes.
Right.
Yes.
So this is basically I'm increasing the magnification.
Yeah.
But that doesn't mean that my
Microscope.
Another term is very important. My resolution is not changing.
Okay.
Okay, can you write this word?
So we learned something called magnification a while ago. Now
Yeah.
we are talking about something called resolution.
So this is very important because let's say I'll tell you a really funny example. If
Okay.
you go to Amazon or Flipkart, something like this, no,
Mm-hmm.
and you look for cheap microscopes.
Mm-hmm.
So they'll say 900 x magnification,
Okay.
1500 x magnification,
Okay.
and that too in let's say 1000 rupees, 500 rupees, or something like that.
Okay. Okay.
And if you don't know the difference between resolution and magnification,
Mm-hmm.
you may fall into this trap.
Yeah.
So for example, let's forget about microscope. I take an image picture with my phone.
Okay.
Okay. And now I can zoom it, that image.
Mm-hmm.
I can keep zooming it.
Mm-hmm.
So much so that now the object which was let's say 0.1 mm in size,
Mm-hmm.
is it now 100 mm in size.
Okay.
So how much is my magnification now?
0.1 mm has become 100 mm.
100 mm.
That is 1 centimeter.
Yeah. So how much is magnification?
Yes.
X. How many x?
Sorry, this is 1 mm. Yes, any responses? Prashant saying 200. Nine.
1000.
Correct.
Okay.
1000x.
1000x.
So is my phone giving me 1000x magnification?
No.
No. So that is how they fool. So what is important is the other term, resolution,
Okay.
which is when you zoom,
Mm-hmm.
how long can you keep zooming so that you can actually resolute or make sense between two objects, 2 points.
Okay. Okay. Okay.
So for example, let's do this. Can you do this,
Zoom in
DP? Just take a one
pollen.
good pollen picture in between
Okay.
and keep zooming.
Okay.
So we can still make out, right?
So let me take this one.
We still make out. We can still make out.
Yes.
We can still.
It's
Now it is
getting,
getting slightly blurred.
the edges are becoming blurred.
Yeah, edges are becoming blurred. Now I think it is difficult to, slightly difficult to say what, where the first object, maybe first border is ending and the second is starting.
Yes. Yes.
Right. So this is resolution. Is it confusing?
Yes.
Yeah. So what is important is that your microscope should have high resolution. Magnification is useless.
Oh. Okay. Okay.
Meaning you have, if you have a good resolution,
Mm-hmm.
meaning then you can magnify as much as you want
Uh-huh.
without basically blurring the image.
So by resolution, are you referring to something like pixels?
Yes. So basically by resolution is, let's say if I take a photo,
Mm-hmm.
this was a photo of bacteria.
Mm-hmm.
So would I be able to differentiate between one bacteria and other bacteria?
Mm-hmm.
If yes, then my resolution is, let's say, 10 or 5 microns, because generally the size of let's say E. coli is around 10 micron, right?
Mm-hmm.
6 to how many microns?
I don't know.
anyway, so basically, what is the smallest object
That
which
your
I can
microscope can clearly distinguish.
distinguish? Exactly.
Ah. And magnification, because once you are digital, you can anyways zoom and get to
Yeah, yeah.
whatever
So
level
your
you want.
camera phone does lot of when you take photo with your phone and when you zoom, no,
Yeah,
your
yeah.
picture resolution doesn't increases.
Yes, yes, yes.
When you take a zoom picture,
Mhm.
it's just the magnification. There is no resolution change there.
But does this logic, Rafiq, like if I say take a very good camera, okay, which allows me to take very high resolution pictures,
Correct.
uh, will I be able to use it as a microscope?
Yes,
Okay.
you can use it as a microscope, or you can use it as a telescope also.
Okay.
So there are cameras with which you can actually see planets.
Yeah, yeah, yeah.
So similarly, there are these macro cameras with which you can actually see polens and all these things.
Okay. Okay. So in that case, like, what is the how much does a typical mobile camera resolution be?
So typical mobile camera is, I think, hardly, you can say, it maybe it be able to differentiate between 5.5 mm.
Okay, okay, okay.
But now you have these really good cameras. Mine one is just 16 megapixel.
Okay, okay. But
So now
this,
I just want to stop here, and then
yeah,
we need to repeat this part.
yeah, yeah,
That
yeah. I think
yeah,
it's
let's get some replies from the participants.
yes.
What they understood. If it is confusing, we can ignore this part or maybe try it another way.
Yes, yes.
Yeah, but let's first check.
So, how much of this were you able to understand, Prashant, Farhan, Shraddha? So the distinction between magnification and resolution, like until today, even I was under the impression that we need to be specific about just magnification when we are looking for a microscope. समझ में आया है क्या? Like, were you able to understand the difference? या जो भी आपको समझ में आया आप बताओ. Let us see.
मुझे जो समझ में बताता हूँ सर.
हाँ.
मैग्निफिकेशन का मतलब ये था कि हम कोई भी ऑब्जेक्ट को कितना मैग्नीफाई कर सकते हैं. और विजुअलाइजेशन का मतलब ये था कि उसमें मतलब वो जो इमेज है, मतलब जो हमने इमेज कलेक्ट कर लिया पहले, उसको जो मैग्नीफाई करने के बाद उसका डिफरेंशिएट कितना कर पा रहा, मतलब दो चीजों को अलग कितना मतलब पहचान पा रहा है आसानी से. मतलब उसके जो बारीकी है, मतलब उसका जो सबसे छोटी चीजों में उसको कितना आसानी से देख पा रहा हूँ, मतलब जूम करने के बाद.
Okay, okay, yeah.
If I'm right.
Yes, Rafiq, is what Prashant, sorry, Farhan saying correct?
Got it.
Yeah. बाकी को समझ में आया, like what is the state of others, like Shraddha, Prashant? So I have a question, Rafiq, like so this is becoming important, the resolution is becoming important because we are using.
Hello.
हाँ प्रशांत बोलो.
Can you fill this image as a landscape and show that 0.5 mm arrow in landscape mode?
प्रशांत बहुत एको आ रहा है.
Can you fill this image at landscape mode?
ऐसा?
हाँ, but वो arrow दिखना चाहिए.
Oh, okay. So you want us to rotate the image and see in the landscape mode?
Means I am measuring on TV. Means this arrow I want to measure in landscape mode. Means if you fill this image, I want to see this arrow.
Okay. Got it. Okay. Okay. So Rafiq, what I was asking was, so the issue of resolution is, or the aspect of resolution is coming to the fore because of the digital displays that we are using to see. And if we are directly viewing using our eyes into the conventional microscopes, right? So in that case, do we still be bothered?
In that case, only magnification will matter.
Yes, because there I think the image is forming on the retina directly.
Correct.
So there we are concerned only about magnification.
So their resolution and magnification will be very similar.
Yeah.
Just to add to this, I think there are two parts of magnification. One is the digital magnification.
Yeah.
And the other one is the optical magnification.
Correct.
Yeah.
So this part is critical because this is a characteristics of the device which we are using to take the image. But once you go here in the digital realm, when you have the image, then I think this, then what Rafiq just shared about the resolution, I think becomes very critical. Am I correct, Rafiq?
Exactly. See, the let's say you take any lens and then you calculate its let's say magnification, meaning object magnification, basically with our eyes. There's no digital involved. So then that is, as Ravi and DP said, then we don't have to worry about all these words.
Yeah.
Hello. Means how you are calculating percentage, means 100 times, 200 times.
I think Shraddha can explain. She did it.
Okay. Means I got 95 centimeter length for this area, this arrow on TV.
So yeah.
You want to take a 95 centimeter as an apparent size and a 0.5 as a actual size.
95 is 950 mm.
Right. Okay.
What is the actual size? Which object did you are you looking at, Prashant?
That is 0.5 mm
line on
this
TV.
Okay.
And 25 centimeter for pollen diameter.
Okay. So this is 250 mm. That's fine. So on 0.5 mm is appearing as 950 mm. So how much is this? It's
1900. Sorry.
1900.
So now just to hammer the point on your screen, the forget about the line. The behind the line, this black line is there, which is actually the grid.
Yes.
Yeah, this part. See this part. This. How clear it is on your screen?
Very much clear.
No, meaning you will see a black, just a black this thing. But let's say, can you see its edges as a sharp, the way you see these hand-drawn lines?
Yes, I can see sharp.
I don't find them very sharp.
Even I on my phone, I don't find them sharp.
I think only the central part is a little thicker, but after that, things are quite
Central part is thicker. Then after that, it is blurry type.
yeah.
Yeah, yeah. Okay.
But
Okay. So
pollen
now
grain
this is,
stages are sharp.
yeah. Pollen grains are sharp. Okay. Now, I think I have sent the link of the app which you can use to do all these things. So what you in the app you do is basically, we know that this from here till here is 0.5 mm. So on the app you give this distance as a reference. So the app knows that this much on this image, this much is 0.5 mm, actual 0.5 mm. Then later on you can actually measure any object on this image in the app. So can you just try to see if you can open the app?
Yeah, so I'm pasting the link again.
Yeah,
Okay.
and if someone wants to download this image, they can download it from the
I have
YouTube link.
okay. I have downloaded that app. I will check it.
Okay, now download this image and open it.
Or I think they can take any other image, like if you also have.
Yeah, but they should have some reference scale in it.
Hmm.
Reference scale of some object of known size.
Yeah, so maybe what should I show one of the pictures which they can quickly
Please,
Screenshot.
I think that will
do?
help,
Yeah.
Ravi.
So should I, if I share the screen, the annotation will be deleted, right?
Yeah, but that's okay. I think
Okay.
Yeah.
So
take
let me
presenter
then.
and
So what you can basically do, I will use the whiteboard first to explain the process, and then I
Yeah.
will show also. How do I go white? Okay, I need
you'll have to upload the default.
Okay, so what you can basically do, you can take a normal scale, a ruler which you have in your house, and you can just mark 1 centimeter. 2 points you can mark with a pen or a pencil, and draw a line,
Perpendicular.
a perpendicular line between these two markings, and take the image of this.
Okay.
So now you know point A, you know point B, and you know that point A and point B are separated by a distance of 1 centimeter. And the target for you will be to find the thickness of this line or the width of this line.
Okay.
Is it clear? Like,
You are now
No.
unmuted.
Please explain.
okay. Okay. So what you have to do, you have to take a pencil or a pen, take a white sheet of paper, mark 2 points 1 centimeter apart. So point A and point B are 1 centimeter apart. ठीक है?
And Ravi, एक बार multi-user बनाओ. I think.
Oh, sorry. Yeah.
Or maybe you draw a line and zoom it, and I think that will make them. Suppose there is a line here. Okay. What Ravi wants to find out is the thickness of this line. Am I correct, Ravi?
Yeah.
So the thickness, I mean, the line actually has a thickness. Like if you zoom in, Ravi, if you can zoom in and into that line, you can see actually that being thick.
Yeah. So yeah, what we need to find out is this.
And now we know that between A and B, the total distance is 1 mm. So we can estimate what is this distance.
Yeah, it might become blurry, and our phone current magnification might not be able to give us the exact result. But I think using this app, we can reach to a good approximation. And I will also show another technique of which you can do it in another software, but that is not available on mobile phone. So just to give an idea of what kind of image I'm talking about, I will also share my screen right now to just show. I think that will make the point more clear. Okay. So is this point clear? Like, or we have any questions and doubts about what we need to do?
Prashant and Shraddha, did you understand what we just did?
Yes.
And we have to draw one perpendicular line in
Yeah,
between.
जो भी line.
जरूरी नहीं perpendicular हो.
Okay.
You draw anything, and because you have a reference.
Okay.
See, वैसे ही अगर रख देंगे लाइन का थिकनेस, डिजिटली एस्टिमेट कर नहीं पाएंगे. So what you have is next to it a standard length which is of 1 centimeter, which will be used to scale and see how thick the line is.
Maybe
And we can do the same, I think, even for hair and this is beautiful.
This is what I want. So we have 2 points, and these are like separated by a distance of 1 centimeter. And now I have magnified this in this software called GIMP, GIMP, and we can have a relative approximation of the thickness of the line depending on how much zooming is allowed. And I will also come to the point of resolution, but maybe we can discuss that after something. So I have like 2 of these images, same images, but with different resolution. And but we'll talk about that like after some time. Is it clear now? Is it clear?
Can you also show us how you actually measure? What is the distance between those 2 points?
Oh, okay. So this.
We don't see your screen now.
Yeah, no, that was simple. I use a normal scale which we have here, and I just put 2 dots like A and B, and these were separated by 1 centimeter.
Okay, so what are you doing on GIMP when you're zooming in?
Yeah, so do we want to like see that part here and then move on to doing this ourselves, or because we were also wanted to explore this image meter app. So so are we? So we can do either of
using GIMP or on image meter app.
Yeah, there are 2 ways of doing it. Yeah, so Rafiq was sharing about the using your phone, how you can do it.
Okay, so let us take our phones and see if we can do what Rafiq just said. Should we all try that? We can take a couple of minutes.
Yes. I have captured. We can see pixel of line also in image.
Yeah. That is what we want. And I think all of us can share our pictures and our estimates in the thread of today's post.
You are now unmuted.
Yeah, so how many of you have managed to open the app? Yes, there is a poll. So I'll bring my scale and I'll measure.
Yeah, in meantime, I will also like just display a post in which using the same technique, how you can also, I think DP was also mentioning how you can approximate the width of hair. So that picture also will give a idea of why we are doing this activity. So like normally, this is how my like, you can see that there are multiple points here. Like these are, I think, 1 centimeter apart. So these points, and this is the hair. And the image which you see, which is overlaid on the background, is the magnified image. So this is an optically magnified image. So I have laid both the images which are of same resolution. Okay, confusing. So we'll talk about this like some other time. But what you can then do, you can do something like this, that you have 2 points and you know the distance between 2 points, and then there is a hair, and then you approximate the width of hair by measuring it in pixel. So this you can do with the gym. But there is also an alternative way of doing it on the mobile app, which currently I think you all are trying. But it's quite similar to like what we all are attempting. But yeah, I think this would have given an idea of like how this technique is helpful and why this reference scale is important.
Means I have downloaded that YouTube image, and I have means label that as a 0.5 mm, means 0.5 centimeter. So what we have to do next?
Ravi, you can share the images I sent you on the Telegram.
Right now you
Yeah.
did you send now? Okay.
Step one is to set the reference scale, and then later on use the measuring tool to find, let's say, diameter of the pollen in this case.
Ah, that's beautiful. What is that? What did you just do?
What is this?
मुझे जहाँ तक लगता है उन्होंने जो ग्रिड है उनके पास वो मतलब वो जो स्लाइड थी, स्लाइड
Yeah.
का उनको ग्राफ पता था, उसके अकॉर्डिंग उन्होंने 0 to 500 माइक्रोमीटर का वो रेंज बता दिया, उसके अकॉर्डिंग ऐप ने कैलकुलेट करके बताया ये जो पोलन है इसकी साइज क्या है.
Yes. So in that app, Prashant, so what it allows you is you can measure a standard distance. You can mark a standard distance, and within the image you can measure any object. Is that making sense? Or is it?
Yes. No, making sense. So we have to first reference scale 1, and then we can, when we draw arrow, we can get measurements.
Yes. So I am measuring thickness of hair on my phone. I'll share that image also in a moment. So okay, that's interesting. That shouldn't be actually.
Yeah, this application actually does the calculation automatically, which you have to like do manually if you are using the desktop software which I was showing.
Yeah.
So this is one of the advantage.
Okay.
So it is showing 0.1, means 1 mm for pollen grains, diameter of pollen grains.
Okay, you took the same image, this one?
Yes. No, first YouTube image.
The one which is, yeah, it's the
On
same one.
YouTube description. No, no.
So this is the one I sent, and the previous one. These are two different photos.
Oh, okay.
So I will check with Telegram.
I didn't share that one because I just wanted to get reading from all of you.
Yeah.
The 0.1 means centimeter, means 1 mm diameter for first image, which is shared in YouTube. According to references, 0.5 centimeter for that blue line.
That's a 0.5. That is 0.5 mm.
0.5 mm. Okay, so I have to correct it.
Yeah, actually I was muted and then I was also speaking.
Oh,
And
I was engrossed
Okay.
in playing with this image.
Yeah.
So
No.
is Shraddha and are Shraddha and Farhan also kept trying to do something?
Yeah.
नॉट अभी नहीं कर रहा हूँ क्योंकि मेरा स्केल मैंने कहीं लगा दिया कट करके, तो अभी स्केल नहीं मैं लेके आऊंगा, अभी जस्ट जाऊंगा तो क्लास का.
Okay. Okay, so I've made this.
So DP, you are measuring the hair width, right?
Yes.
So Prashant took the same image of the pollen which Rafiq shared, and he will share us the value, approximate value, which so let's also tabulate the board with the readings which we get, so that we get an idea of like what kind of values these object, what are dimension of these objects which we are measuring.
Yeah. So Ravi, so the thing is, this is not able to show anything less than 1 millimeter, strangely. So it's
you also have to change the unit, I guess.
Yeah, you can change the unit, DP.
Oh, okay.
On the right bottom corner, there are 3 dots. From there, you can go to settings and
Okay.
change the unit.
Okay.
Okay, so Shraddha has
Make
some
it into
doubts about
microns so that everything is then in microns. So you can give the grid length in microns. That is 500 microns.
Okay, so I'll show my phone, and I think you can help me do that. So just a moment. Okay, so can you see my phone?
Yes.
So I have a picture of a scale, and I have a small hair particle under the scale, and I tried to create a
So reference scale, I suggest DP,
1
you
centimeter.
take at least 1 centimeter.
Yeah, initially that's what I did. Okay, I'll make reference scale as
Longer the better, because then you have a good, basically the error chances are less.
yeah. So when I made it 1 centimeter, what happened was okay. So okay, I made this 1 centimeter.
अच्छा ओके मैं चला के देखो एक बार हाँ वायरिंग फूट गया तो वायरिंग लाना पड़ेगा इधर मिलता नहीं है तो अभी क्या होगा
Ravi,
आवाज आता है
can you see this, Ravi?
Yeah, DP. I can see it.
Now what's happening is I have the reference scale of 1 centimeter,
Yeah.
and
So the app is not able, like with the image which uploaded, it is not able to
go beyond.
bring the pointers closer to the width thickness of the hair.
I mean, even before it's the two arrows meet, it's showing 0 centimeters.
Yeah, can you change the units to like micrometer or something? There is a option of changing the units.
So I go here.
Yeah, and units.
There are image settings.
Scroll down, image settings, then calibrate image, then secondary label on, mode on, off है.
उसमें alternate unit.
हाँ.
Sure.
Inches. हाँ, right. हाँ. So you can see different.
I mean, it's just converting it from one system of units to other, like from MK foot to inches. That's what it's doing.
What is model scale here? Means we have two alternative unit and model scale, and we have to adjust ratio there. What is that?
Rafi, can you guide, like, I don't think the options are too complicated. You just have to, I think, change the unit to DP. Can you see meter, centimeter written somewhere? CM.
So, okay.
I can see meter, imperial means inch, imperial feet, and inches with fractions.
Okay, I got it. Okay, so when I am defining the scale,
yeah.
So I can go to unit.
Yes.
But DP and Ravi, it is not changing the, means it is not showing on that image part. It is showing on picture part, like a map. If you go back to the original image, you can see that when you zoom, we get like a map, 250 centimeter, 100 centimeter, like that, and it is changing.
Have you changed the settings of the scale or what DP was showing?
Yes. I'm talking about that. Means when you zoom or zoom out, you will see at the bottom part that scale. Means like a map. We have maps, and when we zoom, we get idea about what area is covered. Like that, it's showing, not showing the size of that pollen diameter.
Hmm.
Yeah. So I think I could get something.
Right, dynamically it should change the reading to
Yeah.
the respective unit.
So I think it's around 0.2 mm or 280 micrometers. It's slightly less than that, but this is the minimum width that I could measure using micrometer as the setting.
Yeah. So now this is the thing. This is very important point. As we all can see, currently DP is showing the normal image which he clicked using his smartphone,
Yes.
and he imported that in the image meter app.
Yes.
And somehow the approximate value is coming around 300 micrometer. And he can clearly see that the width is even lesser than that, but he's not able to bring the endpoints of the pointer closer than a respective threshold value.
Yes.
So that's why we need to have ways to also click image which are optically magnified, and then we will get a better resolution. Is it clear the need of by attaching that small lens on top of the smartphone, the pointer lens, when we did that, how it helped actually to capture a better magnified image of the same resolution?
And now I can also see the unit. Means for diameter is 81.8 micrometer for pollen grain.
Yeah. So did anyone else also try?
Means that option is when you click line, you will get unit option.
Yes.
Jude is sharing some links. Will
Image test, I think, is another app that IMA test. Okay, so there are some standard images which can be used to test.
Oh, interesting. Rafiq, do you want to add anything here, or should I show the GIMP part?
5:10 now. Yeah.
Yeah. Okay. I think we should also close.
Yeah. So Ravi, I'm out. So basically,
okay.
You can show them gym part and just connect the logic of how it is measured. So what is the app doing? What is very similar to what gym does.
Yeah. Actually, it's very simple maths.
Yeah.
Okay. Thanks, Rafiq. For I will continue with the gym part.
Yeah.
Okay.
See you. Thanks, Rafiq, for joining.
Thanks, Rafiq. Bye. So yeah, like, do you all want to know how we can do it without an app, like with a simple software, which you have to download it on your desktop? It's actually not a simple software. It's actually quite popular open source software, which is called Gym. I think we all can, and it's also it's cross-platform, so you can download that on Windows, Mac, or Linux, any kind of operating system. So I will just share my screen and show quickly the process of like how you approximate the.
We're now unmuted.
Ravi sir.
Yeah. Yes, sir.
How many time for training?
Yeah, so 5 minutes more. I think then we can.
Okay.
Okay. So can you all see the screen? So maybe I will share my entire.
Yes, Ravi.
Yes.
Okay. So in the bottom panel, you can see there are some values. It's written like 215 pixels right now.
Yes.
Yeah. Okay. So now what I will do, I will go to tools option, and in tools option you have to select this measure.
Okay. We don't
is
see
the
those options.
Oh,
I can see. I can see.
measure was
Top-
coming.
After he clicks
top
tools,
side.
the drop-down message things are not visible.
I see.
I think
Okay,
it's
let me share
considered as
the-
another window for another application.
Yeah, now I will show the entire screen maybe. Yeah.
Yeah.
Uh,
So we see some numbers at the bottom, and we need to go to get to tools.
and measure.
Yeah. Shift M also does that. Okay.
Yeah, so now what you can do with this, so I'm zooming in this image. Also, it's you can see on the top in the second row, you can see that the dimension of this image is 320 into 240. Can you read here?
Yes.
So if you multiply it 320 into 240, like how many pixels it will be? 320 is the width and height is 240. So
64
if you
into 12.
Yeah.
Around 640 plus
76800. 76,800.
yeah 76.
Yeah, so around you can say that like it's around 7 megapixel.
Yes, 7.5
So-
megapixels. Yeah.
7.5 megapixels. That's how you approximate the length of the the resolution
Size
of an
of the-
image.
Yeah.
So this entire matrix is composed of like those many pixels. So when we say that like it's 6 megapixel or when we say it's 12 megapixel, it is actually the multiplication of the length and width of the these
Yeah.
two values.
Yeah. Yeah.
So now I'm zooming in, and you can see that the thing is getting blurry
Yeah.
because the resolution is very low. It's
Yeah.
only 320 into 240.
Yeah.
Right, but still like okay, we can still figure out like some blur edges. So what I will do, I went to like tools and measure, and then then you select a point and you drag the make a line using this point.
Okay.
And so can you see in the bottom row it gives the value? Can you all read the value?
27 pixels.
27, and if I increase it, like it will increase the number of pixels.
Yes.
Yeah. So our reference is 1 centimeter is equal to
26 pixels now.
26 pixels, right? And this was the width of the hair. This was the hair, like whose width we wanted to measure.
Yeah.
So this is around how many pixels?
2 pixels.
2 pixels. So if 27 pixels is 1 centimeter, how many? What will be the dimension of an object which is measuring 2 pixels? Simple unitary method, right? So that's how you can approximate.
This is the typical grade 3, grade 4
Yeah.
questions.
Yeah. Just to add another point to add to like what we all were discussing about resolution, I will show another image, but of a different resolution, and you will be able to like figure out the why. Okay.
Yeah, Ravi, I think we should
Close the also. Okay.
Yeah, I think do it faster. Yes.
Yeah, I will just quickly. This one we saw.
It is 0.07 centimeter of that line. For this 0.07.
Yeah. Now can you see the dimension resolution of this image?
Yeah, it's 1280 by 960.
Yeah, can you multiply and figure out the megapixels? Like how much this will be?
Roughly 1000 by 1000, I think. 10,000, no, 1,000 into
12 lakh,
10 power 6.
12 lakhs, 22,
Yeah, around 12
28,000.
megapixel.
Yes.
So, and now if you see, if I zoom in this image, it is not getting blurry. It's the same image, right? But a different resolution. And again, I will do the same thing. I will go to tools, I will go to measure, and I will select the point. And now you can see that the 1 centimeter which we were seeing earlier is now made up of how many pixels?
100 pixels.
100 pixels. So we get a much finer scale with a higher resolution. You can imagine this, the better the resolution, the more finer the scale you have.
Yeah.
To get a precise reading. So now there's 100. So now we can approximate the width. So I can zoom in more and we can, yeah, now this is how much?
3 pixels.
3 pixels or like 4, maybe 4, 5.
5 pixels.
So if 100 was 1, like how much will be 5?
0.03.
5. Yeah.
Yeah, so that's how you can basically approximate the dimension of an object.
Yeah.
And this is the same principle this app is also using, the underlying algorithm of the app. I hope this is clear, like what I showed.
Yes, yes.
Okay, so let's close the session now. Thanks everyone for participating. And sorry for overshooting the time also. Like
yeah, I think we started a little late.
Yeah.
So overall, that's fine. But I think this was pretty interesting. Like we managed to cover quite a lot of ways of measuring things which are very small, and especially like if you have static objects which are and which are captured with a good resolution camera using software like GIMP or digitally, I think you can estimate the size of it if you have a standard thing. So for example, here you know that it's 500 micron and you can estimate the pollen. And in what Ravi demonstrated, we know that the distance between two dots is 1 centimeter, and you can estimate the thick width of any object. So I think we managed to demonstrate quite a lot of jugaad methods of estimating size of very small objects. So hope all of you have.
But I have last question. How to measure that pixel of I have captured that LED part?
Okay.
Part.
Okay.
Because I don't have any reference for that.
So we'll have to keep a reference next to it and take the entire picture and then estimate that.
Yeah, without reference, you won't be able to do it now.
Yeah.
In case of LED, we can measure also normal scale में हम measure कर सकते हैं. I hope.
Yeah, so just place place the scale next to that image and see and capture a picture of that LED screen that you have, and then I think you can estimate.
Yeah.
Also, I think Ravi, you can end the stream now, and we can continue.
Okay.
Yeah.